Hello, we have had a rather extensive introduction to lasers and we basically focused on the characteristics of lasers. Now what I'm going to do is we are going to discuss laser in earnest. So we are going to look at fundamental processes that govern the action of lasing. The active players in this game is the active medium, I'll assume it as just atoms, and light. So to describe these fundamental interactions between light and photon, I should confess one requires quantum mechanics. But I'm not going to invoke quantum mechanics. We are still going to capture the essence of it in a sort of empirical way. So when light interacts with matter, you have a variety of things that are happening. For example, there is spontaneous emission, which is responsible for all the traditional sources of light that we see around. You have stimulated emission, which is what you want for a laser. And you have other non-radiative processes, and there are a family of these effects that can happen. Now remember, quantum mechanics governs the interaction at this scale, and at this scale, everything is probabilistic. And because it is probabilistic, the best one can do is to arrange conditions that some processes will dominate over other. So if you look at the central idea in lasing, what you require is a creation of population inversion. That is, you want the electron to basically sit in an excited state. But excited states are not long-lived. They have a finite lifetime. So eventually the spontaneous emission occurs and the atom comes down to the ground state. At thermal equilibrium, it is spontaneous emission that restores the normal order. That is, all the electrons in the collection of atoms that you have are all in the ground state. Right? So we will look at the thermal distribution. We will quickly realize that at equilibrium, how difficult it is to create population inversion. Basically, undertaking the processes that dominate the lasing action is going to be the story of lasing. At the end of this section, what I will do is we'll look at a simple model that basically captures the spirit of lasing.